All right. Am I set? Because I can't see anything other than Keynote now.
I think you are set.
Excellent.
I see a lot of elephants.
Excellent. That's what you should be seeing. All right. My name is Doug Rohrer. I work at NEO here in the Ohio State, in Cincinnati specifically. I'm going to talk today about something that Erlang is really good at, and we ended up using Elixir to do, which is handling a stampede of connected devices. Real quick about me. I've been doing software development for over 20 years now. I've used a ton of different languages, so picking up something new is not uncommon for me on a pretty regular basis. The other reason that I ended up working on this particular issue is that over the last decade or so, I've spent a lot of time doing performance testing and performance tuning on a multitude of projects in different languages. And before I started working on this project, the only thing I had ever heard about Elixir or Erlang was when Ryan came down to the Cincinnati Functional Programming Group and did kind of an intro to Elixir. So that was my starting point when we started this project up, which explains why we made a lot of the mistakes we did, but also I learned a lot in the process. Talk real quickly about the problem that we ran into. I was working for a home automation company called Nexia. And they have currently tens of thousands of different connected devices, be they thermostats, door locks, cameras, and they are hoping with some new hardware to get into the hundreds of thousands of devices. And that was the point at which we ran into all kinds of problems trying to figure out if Ruby, and specifically Event Machine, which was their previous choice for kind of the background technology for all this stuff, would actually be able to scale to meet their needs in any sort of reasonable way. There's a pretty hard requirement to process messages quickly. So if somebody pushes a button on their iPhone that says unlock my front door, that has to happen pretty quickly. You can't wait for 5 minutes for it to show up at the other end. And again, other than functionally routing the messages, we were talking about the belief and the manufacturing power to have 200,000 just thermostats in the next year. So that was kind of the problem that we were looking at, going from maybe 10,000, 15,000 connected devices into the hundreds of thousands. So a little bit about the process we used. As Rubyists, and the client being a Ruby shop, our preferred technology would have been Ruby, and we certainly started there. But before we went very far, we tried to kind of spike solutions to see if any of them would actually work at this scale. So we kind of talked about this as performance-driven development. We had an existing performance testing tool, interestingly enough, written in Go, that a colleague of ours in the Cincinnati office had already written. We tweaked it a little bit to do TCP/IP rather than HTTP requests, but otherwise it was a really nice, robust, and very high load capable app. And we built an acceptance testing tool for performance. We would then try a solution, see if it worked. If it didn't work, run the profiler against it, figure out what was slow, fix any bottlenecks we could find, and then if in a certain period of time, which for us was about 2 weeks per proposed solution, if we couldn't get to the point where we had some sort of reasonable solution or we knew exactly where we were headed as far as fixing the problems, we would punt and move on to something else. So again, our initial implementation on it was already on Event Machine, and all of this stuff was working fine for the lower number of devices. When you got into a larger number of devices, we ended up with this really interesting, the unbalanced I/O problem, where the Event Machine loop and RabbitMQ, the AMQP gem that you would use to talk to RabbitMQ, would essentially have to drain the entire input queue before it would do any output. So we could pull messages in, process them, and say, okay, send this response back, and then it would sit there in memory for sometimes up to 5 minutes, or as long as it would take to drain the queue. No matter how many instances we had running, no matter how many machines we had running against it, the entire input queue had to drain before any output happened. Um, other people have commented on this who know way more than I do. The folks who wrote the AMQP gem have kind of, although it still exists and is being maintained, they've moved on to getting off of Event Machine, and for the same kinds of reasons, right? You often end up just constantly throwing next tick calls in until you figure out that you can get something to work. It's really hard to understand what's going on. And once you've written it, it's really hard to go back and look at it and go, what in God's name did I do? Even if you wrote it, much less somebody else. While we were working on the Event Machine proof of concept, another group at NEO also built a celluloid, and we tried both Ruby and JRuby as runtimes, implementation of the same thing. Things that we liked: agents are a lot easier to understand than lots of callbacks. Downsides: celluloid uses fibers, which are great in normal Ruby, but when you start running on JRuby, which we found we had to do for performance reasons, they turn into native threads, which surprised me. And we started having all kinds of interesting issues running on Linux without a whole bunch of tweaks. And it uses a lot of memory. And again, I think there may be some programming practices that might help this, but we were at the 40 some odd gigabyte range for 10,000 simultaneous connections, which was a lot and not sustainable. So kind of in summary, you know, why did we punt on Ruby? We did several proof of concepts, tried a whole bunch of different things, including different runtimes. We actually fixed some bugs in the AMQP gem around performance. I'm actually now a committer on the AMQP gem, although I haven't touched it in a while because we got involved in trying to make that stuff work. But it just never really got to the level that we felt it needed to. Really quickly, Erlang was built for this stuff, right? So we thought about what are our other options. The client had actually had a previous solution to a slightly different problem that was written in Erlang and was eventually rewritten in Ruby because they didn't, at the time, need this kind of scale. But they knew that Erlang could handle this kind of stuff. We understood that this is what Erlang is designed for. One of the other things is Erlang gives you clustering almost code-free. There's a couple things that you need to do to cluster an app, but not much. And we knew that no single machine, unless it was a really ginormous machine, was going to handle 200,000 simultaneous connections, and we would rather scale out than up. So we knew that was something that we would want to be able to do. So why Elixir? For us, it was a matter of comfort with the syntax above most other things. And that really drives down to the client as well as our own development staff. I mean, as I said, I've learned a ton of different programming languages. I had to learn a lot of Erlang, especially early on when there weren't a lot of libraries that exist today. We started this on Elixir 0.10 back in September or October of last year. So there were a lot of times where you still had to call into Erlang to do most of what we do in this app. And the other thing was, even if you don't need to call into other Erlang libraries, you will still end up having to learn some Erlang. Just to know how to do things well. You know, most of the documentation and you know how to do X, Y, Z things it's still in Erlang. So as I said at the end, for us, Elixir was kind of a superset of Erlang and better in a lot of ways for us, even though it was a very young language. This is the Elixir group, so I'm not going to spend a lot of time on this. I hope by now you all know what processes in Erlang are and that they're not processes in your OS. I will, however, spend a little bit of time on OTP, which I think even a lot of people who have worked in Elixir probably haven't had an opportunity to try and build a system leveraging OTP. So the Open Telecom platform, which is applicable to many, many things beyond telecom, but that's the unfortunate name that it has, is an abstraction above kind of these more simple or handwritten, at least, actor model where you have a functional piece of code that maintains state via closures. The idea of OTP is to abstract all that stuff away and kind of templatize it so you don't have to keep thinking about those kinds of things. And it gives you a nice, consistent way to handle those issues. OTP is broken down very generically into supervisors and workers. You'll have one of two kinds of processes. You'll either have something that does nothing but supervise other things and either restart them or understand what it should do when they die, or workers that actually do stuff. This is kind of a generic diagram of a supervisor tree where you've got a bunch of supervisors, which are these squares, and then the things that they supervise down at the bottom are the worker processes. It's not a real useful thing to look at because it's just a bunch of circles and boxes, but I'll talk a little bit about our supervisor tree in the AUSLA application, which is a reference to Watership Down, if anybody's interested in how it became known as AUSLA. We have our main supervisor supervises a couple Rabbit processes and a TCP supervisor that handles all the TCP/IP based stuff. So you kind of walk down this tree. If I can, I was trying to point at it. It doesn't want to let me do it. So if you walk down the tree, the TCP supervisor is going to take care of listening, sockets, TCP acceptors, and an acceptor pool. And a number of endpoints, each one of which represents a single connected device. So that's pretty much what I just said. So I want to get into code. 13 minutes into the talk. I think that's probably enough slides. But I like that picture, so I'm going to put it up anyway. We accidentally wrote an acceptor pool, which I didn't even know existed until we started working on this application. One of the things that, one of the requirements that we had was that we needed to be able to pull, to be able to handle up to 1,000 TCP/IP connections, new TCP/IP connections per second. They have observed this behavior in their production environment. If they have a network connectivity loss and then it comes back up, the devices are all programmed to come back 5 minutes after the last time they disconnected and try to connect again. So suddenly you have this giant stampede, thus the elephants at the beginning of the talk, of devices all trying to connect. And 1,000 per second per server was kind of where we wanted to be able to land. And with that, I guess I have to kill Keynote for a minute. So we look at some code. So we're going to talk for a minute about an acceptor pool and what it is and why you should care. With Event Machine, one of the problems we ran into was it could only accept about, and I'm going from memory from 6 months ago, about 150 or 200 connections a second, and after that, they would start just dropping. And to a certain extent, that's not a horrible thing because that means we're going to spread out the amount of time it takes and spread out the load of new connections a little bit. But at the same time, once again, if I'm standing outside waiting for my door to unlock, I don't want to wait another 5 minutes for the door to unlock. So while it had some benefits for the app, it was not very good for the client. Yeah. That one. Tell me if that's better. Hopefully it is. So this is our TCP listener supervisor. So we're kind of 2 levels down in that stack. The TCP supervisor just starts this guy up and handles all of the actual connections. The idea here is that a large number of independent Erlang processes can all listen to the same port at the same time. And the way this ends up working, and it's not only Erlang, any Unix-y type system can do this if the language and the runtime support it. The idea is you have a large number of processes all waiting to accept a new connection. And then when somebody connects, that listen socket wakes one of them up and hands it that new connection, and then the listener can go back and wait for the next connection to come in and not be handling the connection setup and everything else. So this is there we go. This is our listener supervisor, and we have a config file that says how many acceptors we wanted to run. Honestly, we fired up 1,000 of them, and it worked really well, and it didn't seem to consume a lot of memory or anything else, and so we stopped playing with it. That number probably could have been a lot smaller and still worked, but that's just empirically it worked well, and it wasn't causing us any issues, so we kind of left it there. So this thing, in its init, and I'll kind of walk through the OTP part of this real quick. Every OTP process, at least gen server and supervisor, has a start link function that gets called when its supervisor wants it to start, which then will in turn link this process back to the parent process that called start link on it, so that if this dies, the other one gets notified of it. Underscore underscore module is just a cheat for not having to type ausla.tcp listener supervisor. We're passing in that config. We just, honestly, we used a YAML file and YAML, which is an Erlang library for parsing YAML, because the ops people at our client were comfortable with YAML as a configuration file format. So that ends up getting parsed into what now should be a map, but isn't quite yet. And then whatever the name part here has actually changed recently in Elixir 14. This call is a little different than it used to be. It used to be calling directly into Erlang OTP code, and now we've got some nice wrappers around that. And I don't have to give it a colon lowercase atom for the name of the thing. This name you can use in other places to reference back to this when you want to send messages to it. This is a local name, which means it's only applicable to this node. There's another point in the application, which I'll show you in a little while, where we're actually using global naming, which is how we get 99% of the clustering functionality, almost, as I said, code-free. It's not for free because it does have a performance impact of some kind. But so this guy just calls into a init after start link gets called. That then comes into a init. We're going to spawn a whole bunch of calls to starting up acceptors, and you do that because if you block in a init, you can't do other things very well. And there's a whole bunch of different things like calling start child that don't work if you block in your init call. There are a couple different ways to handle this. Spawning a whole bunch of little processes to make those calls is one of them. You can also send yourself a message at the end of init that then you can do that work later. We just stuck with the spawn version thereof. This tree tells this supervisor what kinds of things am I going to be managing, and some information that when I want to create a new one, how do I create it, right? So this guy is going to manage a whole bunch of TCP acceptors, and when I create a new one, I'm going to pass the listen socket, the SSL cert, and the SSL key. We happen to be doing SSL. And every time I start a new one of those guys, pass that stuff into it. We want to always restart these things if they fail. So if a particular acceptor dies for some reason, the client drops halfway through SSL handshake or something, we want to restart all of those things. And they'll get restarted with the same starting configuration. And then supervise just says, go ahead and start up. I want to talk a little bit about strategies, but I'll get to that in just a few minutes, so we'll come back to that. And this guy creates the initial listen socket, which is just pretty typical TCP/IP stuff. And this start acceptor is the thing that gets called X number of times, where for us X is 1,000. You notice I don't have to pass any other parameters to this start child call because all of my acceptors look exactly the same and they have the same set of parameters. So you can just put it in the specification of the worker, which is what this technically is a worker specification. And then I can just say, hey, start me another one of those. And whatever its child is, which in this case, there's a little trick with this simple one-for-one. As I said, I'll get back to that in a minute. It'll just start up a new one of those. So that's a little bit about acceptor pools and why you might need one. I can obviously answer questions later, but I want to move on to the next of the 3 points that I think I said I would make in this talk, and that is restart strategies and what they mean to you and your application. So, as I said, I had never done anything with Erlang or Elixir when I started this project. We built this system, and it was working really nicely. We actually had to run multiple instances of our load test client in order to push enough load against this thing to even slow it down, at least on the Elixir side. Everything was going great. But we would fire up, for example, we would do a test with 20,000 simultaneous connections, and we would have 4 load test clients, each with 5,000 of them. And every time we killed one of those 4 load test clients, the entire TCP/IP side of the tree that we showed earlier, this guy, that guy, there we go, that entire TCP/IP supervisor on down would just implode. It would all crash and then restart itself and be ready to accept new connections. But in the meantime, we've lost all 20,000 of our connections. So we're like, okay, we've obviously done something wrong. Let's get all the other things worked out and make sure we care about using Elixir, and then we'll come back to this. This is when we get into a couple of different things. One is restart strategies, and as I said, I wanted to talk a little bit about those. Generally speaking, if you think about it, your tree is going to be fairly static, where you're going to have a certain known number of instances of children, and if any of those die, you want them to restart. That's what one-for-one means in a restart strategy. That's a pretty typical one. One for all is if all of your children in your supervisor are dependent on each other, you want all of them to be restarted if one of them dies. Rest for one is interesting. So in all but the simple one-for-one case, as you start up children, the supervisor keeps track of the order in which they were started. And it can say if child 12 crashes and I started 20 children, I should restart 12 because it died, but also stop and restart 13 up to 20. I'm sure there's a use case for this that makes perfect sense. I just haven't run into it yet. Simple one-for-one, which is the thing that our acceptor uses, our TCP listener supervisor uses for its children, is designed for starting children dynamically. So when that thing first starts up, it has no children at all. Whereas in most cases, you provide the entire list of worker specs for all of your children in that init call, and then they all get started up. In our case, you saw I spawned a bunch of processes to start up new acceptors, and each one of those got added dynamically into the list of children for that supervisor. Now, you lose the ability to do something like rest for one because it no longer pays any attention at all to the order in which things are created. But in a lot of cases, this is a very useful restart strategy. So that's the first part of this. The second is maximum restart frequency. So the default for both of these values is 5. So if you think about it, what they're saying is if more than 5 clients die within 5 seconds, or children, excuse me, more than 5 children die within 5 seconds, restart the supervisor that's supervising those children and kill any other children that happen to be there and restart that whole process. So this was one of the things we looked at, but we really didn't want to set our maximum restart frequency to, 5,000 in a millisecond, because that was kind of what we were doing with our load testing tool. And in theory could happen with multiple load balancers and things like that. So that wasn't really the right option. This is the answer to our particular problem, which was in that child specification, there is a way to specify what you want to have happen when the child dies. In our acceptor case, which I showed you a minute ago, we always wanted them to restart. So we had permanent as our restart. There's transient, which means as long as the thing dies abnormally. So there's a way you can tell OTP, I want to stop a process, and it's okay that I stopped it. But if it doesn't stop in that way, please restart it for me. And then temporary is, I expect this thing to eventually stop. And even if it stops due to error, don't restart it. And in our case, if you think about the individual endpoints that are connected to these internet-connected devices, the device is always the thing that initiates that connection. And if something happens and that particular process for that single device dies, there's no way we can restart it in any sort of sane state because we don't have a TCP/IP connection anymore. So just let the device reconnect. And this was the thing that actually solved our problem with I kill one of my 4 load testers and my entire process tree dies. And that was to specify that all of our TCP endpoints are temporary and it's okay if they die. So let me take a quick look at the actual code. Typing in the wrong window. Try that again. And this is where we set that up. So this is, I'll go back real quick. This is our main TCP/IP supervisor. That's, again, it starts up the listener and also supervises all of these endpoints. I'd like to point out that I believe there probably should be a TCP endpoint supervisor in here that does this work, and the TCP supervisor should be watching both of those. But again, this was, at the time at least, a spike. And I've got a slightly older version of code. We actually do have that in the app that's being used today. But it also has a whole bunch of other new code that really isn't applicable to what we're talking about. So every time we start an endpoint, we call this same start child method function. I have to say function. And we pass as this last parameter a restart strategy of temporary. And as I said, that was the thing that we finally figured out, oh, this is why our entire tree keeps getting torn down, because these guys would disconnect. You'd have 5,000 things disconnecting pretty much instantaneously. And so the entire tree would tear itself down and build itself back up. So little gotchas and things that we didn't understand at the beginning of this project that hopefully will help somebody else out. I can go ahead and go into some of the other details of this code, but I think I've kind of talked through the things that I wanted to get through in the presentation. I'm happy to spend more time answering questions and talking through stuff. If there's more interest, I can go through more of the code that's involved, the actual endpoints, and can talk a little bit more about that stuff. But this was kind of the end of the talk. I'll show real quick. Maybe if I hit the play button, you all can see this. Some other resources. This is the first of what became a 3-part blog series about this project. So a lot of what I've talked about today is also available out on the neo.com under blog. I am Jeet Kune Doug, pretty much everywhere, on Twitter, on GitHub. I'm hoping to be able to open source some of this stuff, if nothing else as an example application, but I need to get final confirmation from my client. Although, again, a lot of that code is in my blog posts, and they were okay with that. So It might not be Elixir 14 today because I can tell you it's not today. It was written back when this was running on Elixir 0.12. So I will try to get those things updated in the near future as well. The other two developers who were heavily involved in this are Dave Anderson and Jason Vagley, also from Neo. And I want to give them a shout out if they're listening, or even if they're not listening, because I wasn't the only person who did all this work. I just get to talk about it today. So with that, I need to maybe kill this and I can see some questions.
So we've dropped into the chat. So if anybody wants to drop a question or anything along that line in here, go head over to the group chat over on the right-hand side. Hopefully it's showing on your screen at this point. If not, there's on the left-hand side of the Google Hangout, there is a chat button. I will open up the Q&A to see if anybody's dropped anything in there, but otherwise drop it in the chat and I'll take a look at it.
Or are they still in the Q&A? No.
Head over to the chat. There's I'm going to look. Sometimes people like to drop them in the event page as well.
Yeah, there's a couple in the Q&A. If you can bring, or I'll Chris's.
I'll take a look. So I see. Oh, there we go. Questions. Here we go. So, do you want to go? You want me to read them out, or Doug, do you want to read them out?
Go ahead.
Okay. So, first one we've got is from Sunny. I think he was asking you specifically in some of the code, should an SSL start happen in mix.exs in the applications list rather than starting it in the supervisor?
That's probably true. As I said, this is the only experience I've got with Elixir, and you're right. Applications in general should be started in mix.exs. Again, I don't think I knew that until a minute ago. I should have thought about it, but yes, that is absolutely true.
That's awesome, Sonny. Hey, if you happen to have an example gist or something like that where you show starting multiple applications or supervisors that in a mix.xs, that'd be awesome to show. And I'll drop it in the comments or on the event page. Actually, if you want to drop it in the comments or the event page, we'll mention it. All right, so the next is from Ernie. I assume you needed to take on the responsibility to monitor and restart TPC listeners since you stopped having the supervisor handle those restarts. Any gotchas you ran into there?
So this is a little bit of why I think we need an extra layer of supervisor in this whole thing, because honestly, the TCP listener is linked to the listener supervisor and will actually be restarted. There's only one of them, though. There's only a single listener. There are 1,000 acceptors, and those things were also linked with a restart of. Find it. I guess I'm not sharing. I'm not sharing my screen anymore, but.
No, I think we see it.
Okay. If the premise were true, which was we had punted on having the supervisor do that, then yes, you would have had to have taken responsibility for those. So all of the acceptors are restart permanent, and there's only a single listener, which is really this listener supervisor, because there isn't a process other than this gen-TCP listen that is actually a listener. It's really just opening up a port and then handing it off to all of the acceptors, and all those acceptors are actually set to restart as permanent. So if a single acceptor died, it would get restarted on its own.
All right, hopefully that answers your question, Ernie. If it doesn't, feel free to elaborate in another question, and I'll get it over to ask again. All right, so next we've got Trey, I think. Hopefully I'm saying that right. Currently working on a port of the Figaro Ruby gem to Elixir, which uses an application.yaml to define configuration as well. If you'd like to check it out, it uses a YAMLer underneath. Trey, I think I ran across that the other day, looking at some application YAML or some YAML parsers for Elixir. So, but he put a link out there, and I'll drop that link on the event page as well, unless you do it, Trey. feel free to drop it out on that, and we'll try to keep it there because it'll exist long term. So next from Alexi, did you try randomizing the delay before clients would reconnect? Did it give any statistically significant results, like reducing the single second load by 5 to 10%, for example?
So this was something that we proposed to the client before we even started this, right? Because the first thing you think about is, well, if your biggest problem is you have this thundering herd of new connections when everybody comes back at exactly 5 minutes after the drop, shouldn't you just randomize that? And we talked about it with them, and the downside is while some of the devices that are connecting they have enough control over to be able to change those parameters, there are third-party devices that they have no control over and can't change those kinds of parameters. So, for example, the thermostat that we were working with, we could actually programmatically change it when it connected. But because it wasn't a general solution to the problem for all of the devices we had, it wasn't something that we spent a lot of time investigating. But it's a good question and a good suggestion, and we tried to go down the same path.
Cool. All right. I think at this point that's the last question we have. We do have about 15 to 20 minutes left. If anybody has any thoughts, comments, or questions, you can drop them either in the Q&A or something along that line. Otherwise, I am going to put out the August session into chat in here as well as on this past event page. Do that real quick here. August Dayton Elixir, and that will be, I think, on August 5th. So August 5th is the next meetup. There's that, and then also in the chat. There we go. So feel free to register or mark yourself as viewed or going to view that, and you should get a notification at some point through the Google world of emails and notifications, so it drops out there. Otherwise, Doug, thank you very much. Hopefully everybody's registered for ElixirConf coming up, not too long, and then downloaded 14.2. I think that's out there. 0.14.2 of Elixir is out there. I do want to share one of the cool little gems that I've been looking for. I have an app written that works against GitHub issues, and I found that there is a GitHub EX API that wraps the GitHub API. So I've been playing with that. If anybody else has any cool libraries or anything that they're finding or working with, I was thinking maybe we could drop those into some of the next shows in the future, so that at the end we could have something similar to Ruby Rogue's picks that they have. So otherwise, we'll talk to you later. Thanks, everybody.
Thanks.